of x is equal to the square root of x plus 3. Find the inverse of the function and graph both the function and its inverse. So we're going to begin with the function f of x is equal to the square root of x plus 3. One thing I could recognize is that this is the square root function, and it's been shifted up 3 units by this vertical translation of plus 3 units. Another thing I can do is I can make a table of values and graph the function based on the table of values. One thing I need to recognize is what is the domain of the function? What values of x can I substitute into the function? So looking here at what's underneath the square root, we have x. So I'm going to take x and put it greater than or equal to 0. This tells me the domain of the function. So I have that the domain is greater than or equal to 0, and that is from 0 to infinity. I'm using a square bracket here at 0 because of the or equal to part. So if I selected some values to plug into the function and found the corresponding f of x or y value, I'm going to start with 0. And I'll do the function evaluation here. So f of 0 is equal to the square root of 0 plus 3. The square root of 0 is 0 plus 3, which gives us a result of 3. And our first ordered pair is 0, 3. I'm going to continue to choose a couple of additional values for x. And I can pick anything I want as long as it's greater than or equal to 0. But some values I'd like to choose are perfect squares because we have the square root of x. So I'm going to choose 1, 4, and 9. And I'm going to evaluate the function for these values. F of 1 is equal to the square root of 1 plus 3. The square root of 1 is 1 plus 3, or a total of 4. So I have the ordered pair 1, 4. The next value of x is 4. F of 4 is equal to the square root of 4 plus 3 outside the square root. So I'm going to take the square root of 4 first, which gives us 2 plus 3. And 2 plus 3 is 5. So I have the ordered pair 4, 5. And the last one I selected is 9. So if I plug in 9 into the function, we have the square root of 9 plus 3. The square root of 9 is 3 plus 3 for a total of 6. And our fourth ordered pair is 9, 6. And so now I'm going to plot these points. I'm going to start with 0, 3. I'm going to come over here, 0, 3. And that's the first point. The next point is 1, 4. So we have 1, 4. Our third point is 4, 5. And then our next point is 9, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 6. And so if I draw that graph, this is the graph of f. And I'm going to go ahead and label these points. So this is the point 0, 3. The second point is the point 1, 4. The third point is 4, 5. And the fourth point is the point 9, 6. Now, that's the graph of f of x. The next thing I'd like to do is to find the inverse of f of x. So what I'm going to do is I'm going to start by taking this function, f of x is equal to the square root of x plus 3, and replace f of x with y. So if I do that, I have y is equal to the square root of x plus 3. And then I'm going to switch the variables x and y. So I have x is equal to the square root of y plus 3. And at this point here, I'm going to solve for y. So I'm going to subtract 3 from both sides, and that will cancel out. So I have x minus 3 is equal to the square root of y. And I want to remove the square root, so I'm going to square both sides. So square here and square here, and that will undo this operation. And then I'll be left with y is equal to x minus 3 squared. And then I'm going to replace y with f inverse of x. So the inverse function is x minus 3 squared. And so what this is a parabola shifted 3 units to the right. I can also make a table of values for this function and plot some points. So if I do that, I need to consider the domain of the inverse function. I want to come back to the original function, f of x. And we had stated the domain of this function as 0 to infinity. The corresponding range, if I take a look at this graph, from reading it from bottom to top, the smallest y value here is 3. So the range is 3 to infinity. Which means if I come over here to my inverse function, the domain of the inverse function is the range of what I had for f of x. So the domain is 3 to infinity. And the range is the domain that I had for the original function. So the domain here is 3 to infinity. The range is 0 to infinity. If I'd like to take a look at a couple of points, plot a couple points, I can make a table. Picking some values for x. Here I'm told what I can select for x, 3 to infinity. Selecting the first value, 3, and plugging it into the inverse function. F inverse of x is equal to 3 minus 3 squared, which gives us 0 squared, or 0. And so we have the ordered pair 3, 0. And I'll come over here and I'll plot that point. 3, 0. And I'm going to select another value for x, and I can select anything greater than or equal to 3. So I'm going to select 4. Plugging that into the inverse function, we have f of x, evaluating for an x value of 4, f inverse of 4 is equal to 4 minus 3 squared, which gives us 1 squared, or 1. And so we have the point 4, 1. And notice, here we had the point 0, 3. Here we have the point 3, 0. Here we have the point 1, 4. Here we have the point 4, 1. I'm going to select one more. For the next point, we're going to plug in a value of 6 into the inverse function. So I'll select 6. And I have f inverse of 6 is equal to x minus 3 squared. So I'm going to replace x with 6. So I have 6 minus 3 squared, which gives me 3 squared and 3 squared. squared is 9. So a third point on the graph is 6, 9. So we're here, 6, and then we'll go up to 1, 2, 3, 4, 5, 6, 7, 8, and 9 right here. So here we're at 6, 9. And then I'll graph this function. So this is the graph of f inverse. So I labeled the points here 3, 0, 4, 1, and here we have the point 6, 9. So I want to point out on the graph of f and f inverse, the x and y values are reversed. We have 0, 3, 3, 0. We have 1, 4, we have 4, 1. Here we have 6, 9, and on the graph of f we have 9, 6. And lastly, the graph of a function and its inverse are symmetric with respect to the line y is equal to x. And that's an example of graphing f and f inverse, as well as finding the inverse function.